Okay, going on, we've done amino, going on to sulfhydryl. Just simply like that. Sulfhydryl, they can also be known as thiols. Okay. Sulfhydryl works just as well for this class though, just being able to say that. Besides being a polar bond and having each has its own formal charge. It's not an acid, it's not a base, it just, it affects the charge, so really that's about all there is to it. Obviously, like we can see, there's a hydrogen here, so it's always going to be this sulfhydryl, or this sulfur attached to whatever parent chain, whatever's the bigger part of it, okay? And then you have the phosphate. Always have an oxygen there, double bonded, and the rest are just oxygens. And normally, when you see it as a functional group, you're not going to see this oxygen on there, because it's bonded to, like, let's say, it's a functional group, so it's off of a bigger chain. So you'll kind of see it like that. You'll just see it with two oxygens, and a lot of double bonded oxygen, and it'll be attached to something much bigger. One of these was a small acid, or I could be totally wrong. Yeah, it's just that. That's another class, sorry. Okay, yeah. And then also, like all of these, this is a polar bond, so it's going to contribute a negative charge to this overall molecule. As we can see here, it has 2 negative oxygens, right? So it's going to contribute a -2 to the molecule as a whole. And the last was just a methyl, right?
Yep.
Any questions about those so far?
So a phosphate by itself can just be bonded to 4 oxygens?
Yeah, if it's by itself. But if it's obviously bonded to something else, you got to drop one of those oxygens.
Right. And I just will you ever have just a phosphate with 4 oxygens? Or I thought that was kind of like the point of a functional group. It sits on a carbon chain and then
the answer is, like, I don't ever like to say, like, never for anything, because, like, you never know, but and obviously I'm still studying stuff, so there could be cases I don't know about, which is very likely, but you're right, it's a function group, that's the purpose of it, it's off of, like, a parent chain. So
in order to, like, get certain properties.
Yeah, it's a group that's normally just identified in a bigger molecule.
Gotcha.
So you're right, so that's why I do it like this, because normally everything you're going to see in this class is going to be pretty much like this. It's going to be bonded to another thing, and it's just going to have 2 charged oxygens with the double bonded.
Now, is it going to be bonded to 3 oxygens and then bonded to, like, straight to a carbon, or will it be bonded to 4 oxygens and then that last oxygen will be and have another bond to the carbon?
And that can happen too. That happens in nucleotides, actually. So that actually can happen also.
Okay. Just looking at here from the book, it looks like it's still on there, but you're saying that sometimes the other oxygen isn't.
Right. And a good example is, let's see if I can find it. That's what I'm doing right now. I think it's right before this. I just want one DNA. Oh, it's right there. Lipids, proteins. Here we go. So sometimes you're right, you can have it like that, where it'll bond to that oxygen. And then it just continues with the other oxygen up top and just keeps going. So you can see either or. But as long as it has, you know, that double bonded oxygen onto it, and these two of those other oxygens, then you're good to go. So either or works. And you'll learn about how that bond is it this section? I think it's probably this section. These units are going to be going over how that works in DNA. I can't really go over that because I can't get a hit.
Right, that's fine.
So that's also another way to do it. And then the easiest of them all, and actually, it is the only. It's the only non-polar methyl, right? So it just has, it's like this right here. So are you familiar with this? This is a carbon, this is a carbon.
No, I'm assuming that there are hydrogens attached to all of them.
Yeah, you're right. So and this is kind of a little bit of organic chemistry, at least how they like to draw things. Each one of these points is a carbon. This carbon is bonded to this one, that one to that one, right? So it has a possibility of 3 hydrogens off it to have 4 bonds. Same with this one. This one, however, only has 2. So, which part is the methyl on here? The methyl is this part right here. It's a carbon with 3 hydrogens off of it. Kind of like it's just shown on there.
Why is it non-polar?
So the bond between a carbon and a hydrogen, it is so small. Carbon is a tad bit more wants the electrons, but it is so small. It's less than, I think the scale that we use is either 0.05 or 0.5, and it is under that in how much it wants it. So they're basically equally shared. So when you look at the periodic table, you wouldn't think that.
Right. Well, electronegativity, fluorine has 4, oxygen 3.5, nitrogen 3, 2.5 for carbon, for hydrogen, I don't know, it's like 2.5.
Yeah,
something
it's
like that.
right there. It's such a small number that it's basically non-polar.
Okay.
And that's just one to just always have in your head. It's CH, yeah, it's just like that.
Gotcha.
So that's all of them.